Hey everyone, this is lesson 25, and our topic today is writing division answers as mixed numbers. I don't know why we didn't just say quotients there. Quotient is the appropriate vocabulary term, but writing division answers or quotients as mixed numbers, and then also touching just a little bit on a review of multiples. So let's go ahead and take a look at our learning targets for today. Write the answer to a division problem, quotient, as a mixed number, writing improper fractions as mixed numbers, and then finding the multiples of numbers. So this is a really important word as we move forward in our math this year, understanding multiples and really what those are and why we need to understand them to work with them. So writing division answers as mixed numbers. When we do that, we solve a division problem or a long division problem like normal. All the steps would be completely the same, but then when we end up with a remainder on the bottom, that gets brought up and becomes part of a fractional part of an answer. So just to back up for a second, the definition of a mixed number is a number that has a whole number part and then a fractional part as well. So that remainder becomes part of your fractional part. So taking a look here just to walk you through here step by step, 24 divided by 5. 5 can't go into 2, but 5 can go into 24 4 times. 4 times 5 is 20. When I take 24 to minus 20, we get 4 as a remainder. Instead of just writing 4 remainder 4, we can write this as a more advanced quotient or an advanced form of math. We're going to bring this 4 up, and this 4 now becomes our numerator, part of our fractional part of our mixed number, and the denominator comes from this divisor out here. This stays the same. So the 5 comes up here to become the denominator. So 4 and 4/5 becomes our quotient. Let's take a look at this first example. A 15-inch length of ribbon was cut into 4 equal lengths. How long was each piece of ribbon? I'd like you to pause the video and give this a try and make sure that you're writing your quotient as a mixed number quotient, not a remainder. All right, so I'm going to unpause here. I've done a lot of this work already. I have my 15-inch piece of ribbon divided into 4 equal lengths. So 15 divided by 4. I said that 4 could go into 15 3 times. 3 times 4 is 12. So I wrote my 12 right here. 15 minus 12 leaves me with 3. So typically at this point we would say 3 remainder 3. But we're more advanced than that now. We're going to say 3. And then just a reminder, this 3 down here gets brought all the way up to be my new numerator. Oh boy. Okay, so you can see I brought my remainder of 3 all the way up to be my numerator. My denominator comes from my divisor out here on the outside, 3 3/4. Just to double check, so I have a thoughtful label. We're talking about inches of ribbon, so my appropriate answer, gotta get my pen again, would be 3 3/4 inches. Okay. Trying another example. A whole circle is 100% of a circle. 1/3 of a circle is what percent of a circle? Go ahead and pause the video. Try this on your own. There are a couple different ways to go about solving this, but just keeping in mind that the entire circle is 100%. 1/3 of that would be what percent? How would you go about solving that? So I've gotten this set up. I have 100 as my dividend, 100 divided by 3. So because we're asking 1/3 of a circle is what percent. And I know that in this case, we're talking about mixed numbers. So I'm going to do what I can to produce a quotient as a mixed number. So 100 divided by 3, 100 isn't evenly divisible by 3, but I know that 3 times, well, let's just go here. Can 3 go into 1? No. Can 3 go into 10? Sure. 3 times 3 is 9, and that's pretty close. So 10 minus 9 leaves me with 1. I still have a space left to fill here, though, so I'm going to drop down my 0. Again, can 3 go into 10? Yes. I'm going to... Can 3 go into 10? Yes, 3 times. 3 times 3 is, again, 9. And I have 1 left over. And I'm at the end up here. See, I don't have any more spaces to fill. That makes my 1 down here a remainder, and we're not working with answers like that right now. We need to turn this into a mixed number. So my whole number part is 33, but I have a little left over. I'm going to put this in a mixed number form. 33, I'm going to bring this 1 all the way up to be my numerator. And my denominator comes right here from my divisor on the outside. Ooh, I don't think that worked very well. Okay, so we have 33 and a third percent. What percent is 1/3 of a circle? 33 and 1/3%. Write 25/6 as a mixed number. So this is a review. This is something that you may have started seeing in 4th grade, a really, really important skill. Again, something that if you don't do on a regular basis, you probably don't remember how to do it. So writing this as a mixed number. If you'd like to pause the video here and give this a try on your own before watching me work, I encourage you to do that. Otherwise, I'm going to jump right into solving this. 25/6 is the same thing actually as 25 divided by 6. That's really another way we can think about fractions. This fraction bar is also a division bar. So 25 divided by 6. I can actually talk through this mentally, but I'll work through it on paper as well. So mentally, I'm going to ask myself, well, how many groups of 6 can fit into 25? Well, 6 times 4 is 24. So in my head, I'm locking the number 4. 6 times 4 is 24. That's going to be my whole number part. And then 24 is how many away from the one we're asking about? 24, 25. 1 left over. I have 1 left over. So I'm going to have 4 and 1. That becomes my numerator. 4 and 1 sixth. So I'm saying mentally, when I solved this, I got 4 and a 6th. I'll actually solve this out long division way. I have 25 divided by 6. This is just basically putting down on paper what I just talked through mentally. 6 can go into 25 4 times. That, in fact, is 24. 1 left over. I'm going to bring that up to become my fractional part. We have 1/6. Same answer. Good deal. This is a little bit of a review on multiples. So when we find multiples of any number by multiplying the numbers by 1, 2, 3, 4, 5, and 6, and so on. This, again, if you know me as your math teacher, I don't like too much wordiness when it comes to math. I feel like it makes people overwhelmed. It gets to be too much. Think about the word multiples as multiplication facts. So knowing your multiplication facts of numbers. For example, if I'm talking about the number 3, I know that the multiplication facts of 3 are 3, 6, 9, 12, 15, and so on. Multiples are infinite because numbers are infinite. They don't ever stop. Multiples and factors get easily confused. Which ones are which? Factors are the smaller numbers that can be multiplied together to make a number, a given number that we're looking for, and those are finite. There are only so many of those. But multiples are infinite. There's no end to them. They stop whenever you stop. So multiples are multiplication facts. Multiples of 10, for example, are super easy. We've got 10, 20, 30, 40, 50, and so on. Multiples of 2, 4, 6, 8, 10. Multiples don't stop. They're just the multiplication facts. What are the first 4 multiples of 8? This you could do in your head. By now, you know your 8 facts. I've told you this in class before, but I'm not always so good about my 12 facts, especially when we get beyond like 11, 12, like 12 times 11, 12 times 12. I don't know those always off the top of my head, but 8's feeling pretty good about. So what are the first 4 multiples of 8? Well, the first multiple of any given number would be itself. So the first multiple of 8 is 8, right? Not to be confused with the first factor of every number being 1. First multiple, 8 times 1 is 8. So we've got 8, 16, 8 times 2 is 16, 8 times 3 is 24, and then 8 times 4 is 32. So let's write these out. We have 8, 16. I'm writing this with a mouse. We have 24, and then 32. They specifically asked for the first 4, but we know that these are infinite. We could go on and on and on. What number is the 8th multiple of 7? Couple ways to think about this. We could write out all of the multiples of 7 until we get to the 8th one, or if you'd like a shortcut, good mathematicians find shortcuts. They're really asking, what's 7 times 8? We're talking about multiples of 7. If we get to the 8th multiple of 7, we're just asking, what's 7 times 8? Boom, done. 56. Right? That's our last practice for today. Understanding multiples, this is not the last you're going to see of them. This is really just kind of amping us up to do some work with least common multiple, finding common denominators, and doing some work with fractions.